My name is Sebastian. You're in the Computer History Museum, and I've been asked to give you a history talk, mostly because the stuff I'm up to right now is very boring. But in the past, I did something interesting that might be relevant to your work, and maybe, who knows, maybe impacted your work a little bit, a tiny bit here and there. And that is autonomy. I approached autonomy as a Stanford professor, thinking when I'm gone, I want to have a little clone of myself that can run around and talk to my kids. That didn't quite work out. But then I've worked laboriously on computer science to make machines smart and give them AI. And long before working on what you are working on, cars, I worked on the indoor equivalent. This is now an embarrassing, almost 30 years ago. 20 years ago. 30 years ago, sorry, my math is bad. Where we built robots indoors that are like cars indoors. They would navigate spaces like your cafeteria, or in this case, a Smithsonian museum in Washington, D.C., guiding tours to kids. And that technology matured as we started to go underground into abandoned mines in Pittsburgh, Pennsylvania, building robots that entered these poisonous areas, deprived of oxygen, to map them. And that eventually led me to look into cars. Why cars? Because there's 100 million of those. They felt fairly brittle. We killed over 1 million people a year worldwide in traffic accidents. So after we built maps for abandoned mines where we killed nobody, we started building maps for cars. My personal car story starts around 2003 when I relocated from Carnegie Mellon to Stanford University here locally, not far from here. And I encountered a competition sponsored by the US government called the DARPA Grand Challenge. Anybody here heard of that before? All right, at least 10 people, thank you. All right, probably more. 2003, the US government had decided that they wanted self-driving cars, mostly in Iraq and Afghanistan, because improvised explosive devices killed good Americans, wealthy, nice, friendly, well-educated, well-meaning Americans. And by putting the driver out of the driver's seat, they could deal with logistics and other things in defense using robots. They got together a competition by which Congress appropriated $1 million as prize money for the team that could build the best self-driving car, as measured not far from here in the Mojave Desert on a test range between Barstow, California and Primm, Nevada, a desert trail effectively where these vehicles had to drive. This is one of the competitors. Just not visible on this image is the starting pole. It made it just beyond the camera frame before it hit a berm, a tiny berm, and flipped over. And that was kind of the state of autonomy in 2003. They were one of the better performing teams. Out of 106 competitors, 17 were allowed to the race, and only one made it more than 1 mile. And that was Carnegie Mellon's robot that burned in flames at mile marker 7. So that was, if you come home to your team and they say there's been very little progress as of late, refer them back to 2004, at which point driving even 10 meters was a challenge. That was the state of the art. And it was not a hardware problem at the time, it was purely a software problem. So this vehicle could have easily stayed on the trail and not flipped. It was this lack of perception of the environment that caused it to flip. And fairly said, in 2004, other than being able to read GPS points, there was just no robotic perception in this field, for most parts. I had just accepted a job at Stanford. I didn't know what to do with my time, so I decided to enter the race. We worked with a German car manufacturer, Volkswagen, that gave us 2 free Touaregs. Touaregs was the Atlas of its time, a diesel-operated vehicle, and we bolted onto the vehicle a suite of sensors. You're familiar with those. They're much sleeker, much nicer now, but even then, laser rangefinders, cameras, radars, of course a GPS sensor, an IMU, and so on. And we plugged into the and trunk of the vehicle, 6 CPUs that in total had less compute power than my iPhone today. Because I didn't have any money for this, I decided to teach a class. We called it Projects in Artificial Intelligence. And one of the nice things at Stanford is if you're a professor, normally all of you, for your staff, you pay them, right? So they take money home so they can feed their family and so on. At Stanford, it's the opposite. The students pay you. So they come in and pay tuition so they can work for you for free. So we got 40 students to work with me for free through this class. I said the class is to win the Quantum Challenge. Within 2 months, you're going to build a robot that can drive in the desert. 20 students, the smarter ones, all left and never came back, and the lesser ones, they stayed. And then we started building our car, very ambitious. This is the day, this is our car. That's the day when the New York Times, John Markov, visited us for the first time to write an article about us. And he did write an article, and the article had like a headline, something say, not quite ready. But our competitors at Carnegie Mellon went into the same problems. This is their vehicle just a few days before the race. They flipped it. So it was literally the Wild West of robotics at the time, where you got together. Luckily, no humans were harmed in these experiments, but you can imagine how life felt hanging out in the desert day and night, trying to tame the beast. The race itself, oh, this is my favorite. This is UC Berkeley. You should know there's a rivalry between Stanford and Berkeley. So we love to show their research. This was a day, coincidentally also the day the New York Times visited them, Anthony Lewandowski. And they found out that Linux is not waterproof. All the type of stuff you worry about every single day when you build your cars. So the race itself, now we're talking 2005, long time ago, unfolded early in the morning. These cars were completely empty. Behind each racing vehicle was a chase vehicle that had a so-called e-stop, so to avoid the worst thing. And about 100 miles into the race, our vehicle was second seated, got the chance to pass the first seated vehicle, and had to navigate what to us looks easy, but towards the time was very scary, treacherous mountain passes. At the time, the rover was completely covered in dust. Its sensors are basically blind, not quite, but almost blind. It now has to slowly navigate through this desert trail that is appropriately called Beer Bottle Pass. And about 6 hours, 53 minutes in, it emerged from the desert. We saw a blue dot, we saw a helicopter, and eventually saw the cheering crowd. This is the finishing line. There's about 1,000 hardcore nerds in the audience. And that is the moment that wrote history for self-driving cars, because that's the moment where Larry Page, who happened to be here at the race, started realizing, wow, this is something we should do at scale. The car itself is now in the National Space Museum, but in Washington, D.C. But the very first transition of technology moved into something else, which is Google Street View, where we built a fleet of hundreds of cars to map the Earth. I'm sure you've used it before. It's the same technology. And it was the part of technology that was easy to manage, not the robotic stuff that makes it hard. We can drive wrongly, but just the perception stuff, the mapping stuff. So you're able to build the world's biggest photographic data set ever built to the present day, I believe, with massive numbers of cars. The only way to transport the data was by FedEx truck. It wouldn't be able to transport it digitally. It's too large. It's like exabytes of data. But you can see, feel for how this technology already had an early impact in products. 2009, Chris Urmson of Aurora fame now, Anthony, a bit of this fame, and myself launched Waymo. We called it the chauffeur product. And we started out giving us a challenge to say, hey, can we possibly drive a street on public roads, a car on public roads? The immediate response was, heck no, it's dangerous. There's like children playing. You know, a self-driving car in the desert is one thing, right? Worst case, hit a turtle. But now you go to downtown San Francisco, Lombard Street, you're going to kill real people, Larry. And Larry said, Sebastian, give it a try. So we carved out this 1,000 reference miles all the way down Lake Tahoe. You can see all the major bridges in the Bay Area, a coastal road all the way to Los Angeles, and so on, as a way to prove to ourselves you could drive in public streets. And the idea was to drive 100% hands-off, okay? Not every run was hands-off. Sometimes we had to take over, but we wanted to do every single one at least once hands-off. And that took about a year and a half. we drove these modified Priuses. We had not worked with Toyota. We just bought them and we hacked them. They're easy to hack, turns out. As are all cars. And then we drove to Palo Alto. This is now a long time ago. People stopping us, ask what you guys are doing, would say, yeah, we are kind of a weather station or all kinds of crazy. We're tracking satellites. We do air measurements. No one had a clue, even cops that pulled us over that we had a self-driving car. But it worked quite well. And we really got the DNA together to do what's done today. If you go into a self-driving car today, what you see is not dissimilar from this video, except it doesn't want to play. But you can imagine this. You see a 3D representation of the world as manifest by radar and lidar measurements. On top of it, there's usually a classification of the objects you see, lane markings, buildings, other cars. There's a calculation of intentions, how they interact, and so on. And all the way to a very high-level reasoning, where to go, how to communicate with other vehicles, and how to talk to the passengers. As early as 2011, we had our very first full-blown taxi service, which people don't know about because they never publicized it. But we had a set of golf carts on Google's campus, and they were truly unmanned. Back in the day, the laws didn't exist yet, so you could do crazy shit. We later sponsored those laws, and we learned a lot about what not to do in legal worlds. But we made these things come, and you had a little handy cell phone, and it would come to your desk, and then it literally would pick you up. These golf carts drive, I think, 25 miles per hour max. But other than that, they can also kill people. So you can see them zip along, picking up people. And people could, this is a typical Googler. Google has a lot of free food. It happened to me too. It's called Google 25. You badge in, and then you take this vehicle. Either you drive it yourself with some people or other people who just want to get work done. They could just sit in the passenger seat and be ridden by it. And that was, we tested for a few months. There's kind of an early feeling that there would be actually utility in having a taxi service, because that would mean you could share vehicles. You could make it more economical than car ownership, and you don't have to worry about parking anymore. So it was a pretty fun thing to do. Here's a person who's taking a phone call, and it's just a passenger, an early passenger on self-driving cars. The rest is history. We launched Austin. I had, at the time, left the team. Dmitry Dolgov eventually took over. Phoenix and San Francisco. And those of you who have a chance to be or live or stay in San Francisco, there's no way you can spend more than 5 minutes there and not see a self-driving car. There used to be two companies, Cruise and Waymo. I forgot what happened to Cruise, but Waymo is the surviving company. And I recommend taking it. It's actually really fun. If you think about the future of traffic, these vehicles are actually objectively safer than human drivers. Mostly because we suck, we text, we drink. The robots don't do that. They're not quite as elegant yet. So when it comes to total time spent in transportation relative to Uber beats Waymo, but they're getting better. And the nice thing about self-driving cars is they learn differently, right? So if I assume most of you had at some point made an error in traffic, maybe some of you even caused an accident, I have, and then we learn from it, and we avoid that same mistake hopefully in the future, but no one else learns from our mistakes. We all make the same mistakes. Whereas in self-driving car land, with one robot makes the mistakes, they come home with this knowledge, and then we take that knowledge onto the disk drives and copy it, and the next day, all the cars will avoid the same mistakes. So as a result, the robot have a learning curve that just outpaces human learning and driving. And it's already reached the point where for most driving situations, these cars are safer than people. So now it's more of an exercise to downprice them, to make them cheaper than human drivers, so that eventually they can take over the world. Out of my effort came adjacent things. Aurora is a spin-off from Chris Urmson, who was my team lead and former grad student. Neuro is a former grad student and former team member of mine, and Zoox is a former grad student of mine. And you can see the DNA of self-driving spreading in my world. I wanted to originally also speak a bit about flying cars, but I got discouraged from the leadership team to talk about this. So I'm going to talk about what I've learned in this process of building self-driving cars. there are 3 types of learning: technology learnings, business learnings, and then personal learnings. Of course, they were the most interesting. Technology learnings is, I think the last 20 years have been a thrill ride in advancement, and all of you are part of it because you're doing the same for your companies. And you make cars safer and better and more economical and safer. That's great for the world, given the high fatality rates. While we are building the Google self-driving car, the technology shifted into deep learning, and there were some of us in the field who made claims such as, you can drop lasers, you can drop radars, you can drop almost everything, 3D geometry. All you got to do is learn like a person does. You just observe lots of stuff, you drive around, and eventually you get the competency. I would say at this moment, the progress on the camera-only based and the representation-free machine learning is staggering, but insufficient. So when I look very critically at the accident rates and types, machine learning alone proved insufficient so far, be it alone for the simple case that cars continuously encounter situations that you never train for. If you go and look at autopilot type crashes and ask what caused that crash, very often the situation is a situation that's so unlikely and so bizarre that it's hard to train for it. All of us, when we drive cars, we don't train for tractor trailers flip over the middle of the night with 2 police cars. Cameras also, I know there's a big debate going on in the world of the one company that bets on cameras only has made great progress. I would say for safety purposes, especially in situations that are unrehearsed, having a distance sensor, a radar, a laser has proven to be indispensable if you want to be 100% reliable. And that's been a bet and debate from day one, and to the present day, I have not changed my mind, even though cameras are getting better and better. Now, Larry Page told me eventually cameras will do it because people can drive with less eyesight, and that's correct. Eventually, cameras will catch up and be good enough. But even from a liability perspective, I would think having a cheap radar or laser is not a mistake. What are the business learnings? They're interesting. Just last week, and I flew back with Anthony Tam, who runs Grab, which is a major ride-hailing service in Indonesia and Philippines and so on. And he told me that the current cost per mile has come down to roughly 50 cents, including the driver. And something we can't quite do in the United States because drivers are more expensive here. I think an Uber cost to consumers about $1.50, like 3 times as much, where about 60-70% is a rider. In China, about 50% is a rider. But in these poor countries, especially if you're willing to ride a motorcycle, it's getting very cheap. And from a user experience perspective, a Grab and a Waymo is the same. Like, I don't speak Indonesian, so if I enter a Grab, I can't talk to the driver. So from my perspective as a customer, this is just like a self-driving car. So there's an open question if this technology can get lower to a level where it becomes competitive with human drivers. If you consider the human driver part of the self-driving system that you don't talk to, which is a fair statement because if you enter it, it doesn't really matter whether there's a person inside or a computer. There's certainly a challenge from today's technology to get to the point where you're financially competitive. And I would say, not knowing the details about the current budget and unit economics for some of the leading competitors, my suspicion is it's a big challenge for the existing players right now at this moment. Now, luckily in Silicon Valley, you can make up with this, go to Massa and get a big check, and then pay for everything. But eventually, I think we have to make this economical. So what are the personal learnings? Ton of fun. This is the stuff I was asked not to talk about, but I talked about it anyhow. Because around 2015, I decided to switch over to flying cars. And I know you're not working on this yet, but let me water your mouths for this, okay? So why flying cars? Just imagine you invent technology that lets you level up your Porsche, what have you, like 500 feet up in the air, okay? And let's say you can do this for free, okay? Just sits there in the air. What can you do now? First of all your safety concerns are gone because almost everything to hit is on the ground. Gravity confines all the stuff that you want to avoid to the ground. So you're basically on your own. And then you go in a straight line, right? You don't need a road anymore. So this massive investment infrastructure that we've done with roads and so on can go away. We believe in the Bay Area. We've proven this. You can go roughly 6-7 times as fast as ground transportation. You can do this roughly at a third of the energy. It turns out flying is actually energy efficient. it's counterintuitive because thinking yourself lifting something up is hard. But keeping a plane in the air, typically you spend about 10% of your energy on lift and 90% on drag. And the higher you go, the less drag you have. And you could immediately take away all traffic accidents because the air is so big. The roads are one-dimensional, the air is three-dimensional. And that makes all the difference. So if you come into a situation like this, you can just go above and avoid. So from that perspective, I would say, other than us being like stuck with what others would consider the horses of their time, cars, I do see a future where we go through the air. And there's now many, many companies working on this. We sold our company to Boeing. It's called Whisk. But there's a whole bunch of new startups. And if you go to smaller stuff like packages, Zipline and others making amazing progress. So as a heads up for the business in the next 10 years or 20 years, expect this technology to make an impact. So at least want you to know about it. With this, my time is up, and thank you for having me.